We're going to look at what is called solution problems. Now, these are not always easy to do, but if you will follow the method, they do make sense. Now, if you are a farmer and you need to put chemicals or some kind of fertilizer on your various plants, many times you have to mix them into certain specific proportions. And so as you mix them together, if you mix the chemicals together correctly, they will do the job that they have to do on your plants. But if you don't mix them together correctly, then you end up with plants that are not as healthy as they should be, or you end up with a lot more weeds in your crop, and it's hard to get your crop. So this is a skill that I have helped farmers actually do over the phone. They knew that we knew how to do it because it had a math class, and they remembered that we had done it in class, but they couldn't remember how to do it. So they called me on the phone and I walked them through, and they were much more complicated than the ones I'm going to show you, because we were not only working with the various solutions, but we were working with various different measurements, and so we had to constantly be changing back and forth between measurements to keep everything in balance. So it's not easy to do these that way. So as we look at these solution problems, in these problems I use what I call buckets. And the reason I like the buckets is because everything is pretty well cleared and lined out. I will also show you how to do them with a chart that a lot of people like as well. So I'll show you both methods because some may like one and some may like the other. So the first method, using a bucket. Well, before we go any further, first of all, let's look at just a simple solution. If I say I have a 60% alcohol solution, and there are 100 liters of alcohol, how many liters are alcohol and how many liters are water? Okay. So think about this. Here's my container. It has 100 liters in it. If I have a 60% alcohol solution, that means 60% of this alcohol solution is alcohol, and 100 minus 60 means that 40% of this solution is water. So I'm going to draw a line here. This would be my alcohol, and this would be my water. Okay? Of course, it's going to be all mixed up together when you put it together. So 60% of 100 liters. 60% can either be written as 60 over 100, or you can do 0.60. Move your decimal 2 places to the left. 60 divided by 100 is 0.60. Now, I can either multiply 60 over 100 times 100 liters, or I can multiply 0.60 times 100 liters. And I don't mind if you use your calculator. But look, 100 times 1 over 100 in the denominator, this is 100 divided by 100, which is 1. So 60 times 1 is 60. So my alcohol has 60 liters, and 100 minus 60 gives you 40 liters for your water. Okay, so that's what we're looking at, is looking at solutions. Say I had a 45% alcohol solution, and instead of 100 liters, how about 1,000 liters? Okay. So let's look at the new solution here. We have 45% alcohol, and we have a total of 1,000 liters. And 45% alcohol, so you have alcohol and water. 45% alcohol, okay? So 0.45 times 1,000, and if you're going into nursing, you'll have to put that 0 in front of your your 0.45. I'll try to remember to do that. 0.45 times 1,000, multiplying by powers of 10, you have 3 zeros, move your decimal point 3 places. So my alcohol is 450 liters. If there's 45, that means I have 55 water, 0.55, again, times that 1,000, move it 3 places, gives me 550 liters of water. Or I could have said 1,000 minus 450, give me 550. So that's your basic multiplying your concentration times your amount to give you how much of that solution is being carried by the name that we have given. So now let's look at another one. In this one, we're going to look at 2 solutions added together. All right, so 2 solutions added together. What are we going to end up with here? Well, let's say we're going to mix together how much of a 10% solution must be mixed with a 30% solution. Okay. Now let's change that to mixed with about 40 milliliters of a 30% solution to get a 20% solution. Okay, there's a problem. Okay, we've got 2 solutions. We have a 10% solution. We have a 30% solution. We don't know how much of the 10% solution we have. It must be mixed with, that's your addition symbol, a 40 milliliters of a 30% solution. So we know how much of our 30% solution, and we want to end up with a 20% solution. So when we're working with these, we put our concentration on the top of the bucket, and the quantity goes inside the bucket. Okay, and this is solution number 1, solution number 2, and it's going to give us our final solution. Okay, so my concentration, think about our first bucket. It's the first part here. How much of a 10% solution? So our concentration is our 10%. The quantity, how much, we don't know, so that's going to be our variable. And it's going to be mixed with 40 milliliters of a 30% solution. So our concentration is our 30%, and our quantity is 40 milliliters. And notice, I put down the unit of measure in my box so I don't forget it. And we want to end up with a 20% solution. Okay, but how much do we actually have? I don't know about you, but I cook from scratch. And because I cook from scratch, when I go to make muffins, I put my egg in my measuring cup and I beat it up. Then I kind of look and see where it is. I pour my oil on top of it and then pour my milk on top of that. So I am adding to what I started with. So this one, this is what we started with, this unknown amount. We added to it that 40 milliliters. So therefore, my total amount is my x, that unknown amount, plus my known amount, which is 40. And that's my final amount. Some of you may mix together punches and things for a celebration or for a graduation party, and you're going to put pineapple juice and maybe orange juice and maybe 7-Up or something. So you put certain amount of each one of those, and the quantity just gets bigger and bigger, right? Because you keep adding more in. Well, that's what's happening here. I start with some, and I add more in, ending up with my x plus 40. Now, just like over here, we multiplied our concentration times our amount. Since we have percentages on every bucket, if we choose, we do not have to change them to decimals. But if you want to, you can change them to decimals, because when we go to interest, you will have to change it to decimals. So we can do it either way. You can either use your decimal equivalent, or you can use your percentage, and because they're all in percent, it works. So you have, I like to do my 10x plus 30 times 40 is equal to 20 times my x plus 40. You see how this one has, the whole thing is in parentheses, because this whole expression is the amount. So it's concentration times quantity, build your equation. So I've got 10x plus 1200 equals 20x plus 800. Okay? I'm going to subtract my 10x from both sides, and that's going to give me 1200 is equal to 10x plus 800. Now we're going to subtract 800 from both sides. And I'm going to have 1200 minus 800, which is 400, is equal to 10x. Now divide by your 10. And so 40 is equal to x. Thus, my 10% concentration has 40 milliliters. So 40 milliliters of the 10%. Okay, I'm going to show you how to solve that same problem using a chart. Our solution goes here, our concentration, and then quantity, and then results. Okay? Okay, first solution. And I have a 10% concentration, and I don't know how much. My second one had a 30% concentration, and I had 40 milliliters of that one. And my total concentration was a 20% concentration. Maybe put final here instead of total. And my quantity is my x plus 40. Notice, if I don't have anything here and I have something in each of those, it's an addition. My results are 10% times x is 10x. 30% times 40 is 1200. And 20 times x plus 40. And right here is your equation. 10x plus 1200 is equal to 20 times x plus 40. And it solves the same way. It's just another approach. Some students really like this, some students really like that one. I really don't care which one you use. Use the one that makes the most sense to you. Some students, the little boxes seem to work better in putting it into the chart. Others, because this has your equals and your plus in it already, they find that one easier. So it just depends upon you, the person. So let's look at another one. Okay, here's a different kind of one. If 20 liters of a 20% solution is mixed with let's go 50 liters of a 50% solution, what is the final concentration? Okay, so we're looking for the concentration on the last bucket. So let's put our buckets in. I'll do this one both ways too, so you can see it. Well, my concentration, my quantity, we're going to multiply. So my solution number 1 has 20 liters of a 20% solution mixed with 50 liters of a 50% solution. How many liters do I have? Well, I have 20 plus 50 is going to give me 70 liters of, I don't know my solution, X percent. So I don't know that solution concentration. But again, this times this, and that times that, just like the other. 20 times 20 plus 50 times 50 is equal to X times 70, or 70 times X. Now, this is 400 plus 25 with 2 zeros equals 70X. Add these two together and I get 2900 is equal to 70X divided by 70. Gonna lose a 0. 7 goes into 290. Well, it goes into 29 4 times, carry my 1. Goes in 1 and 3 sevens. If I had my calculator, I'd go ahead and do a round it off. But 41 and 3/7% is my concentration of my final one. And that's final concentration. Okay? And I didn't bring my calculator in, so I can't give you the decimal, but the decimal would be, let's see, 41.42 would be, let's just go 41.4%. That's an approximation. All right? So let's do that same one now in the other form. here we have solution, number 1, number 2, and final. Concentration, quantity, and final. Okay, concentration gives me my 20%. My quantity is 20 liters. And this is 20 times 20. Number 2 is a 50% concentration with 50 liters. And it has a 50 times 50. This is my unknown, I don't know my concentration. 20 plus 50 is your 70 liters. And this will be 70 times X. So 20 times 20 is 400 plus 2500 is equal to 70X, and you can do it from there. So you see, both of these are good methods. It just depends upon which method you like best. Okay, and that is the end of our radical equation and solution worksheet. So you are all ready now to do the work that is involved in this particular worksheet. Good luck, have fun.